Hi, this question is about translational dynamics, and you see that a box which is slided on a horizontal board on the earth, when it is slided, it experiences a frictional force equals to F0 according to the question. So it will be against the direction of motion, so that must be in this direction. So this is F0. But what are the other forces that we cannot ignore? The one force is the force of gravity, right? So let's say it is mg, and the other force is an equal amount of force applied by this horizontal board, and that must be the normal force. So these two vertical forces are balancing each other, and the resultant force is this frictional force. And it is a dynamic force. Dynamic friction. So I can write its value equals to, if the coefficient of friction is mu, so I can say it is mu mg, right? Now, this same block is taken from the Earth to another planet whose radius, according to the question, is twice. So you see that the two are, whereas its mass is one third of the mass of Earth, right? So why they are giving us this information? Because by acquiring this information, you can find out the force of gravity and gravitational field strength. Okay, so just for the reference, I have shown you these field lines which are around the earth, which are the imaginary field lines which represents the gravitational field around the earth. Okay, now the gravitational field around the earth is, we always depict them with the help of these lines. So, for example, if the block is placed over the surface of the earth, just like you see here, then the earth pulls it towards its center with the force of mg. Now, if you place the same block over the surface of this planet, right, which is bigger in size than the Earth but lesser in mass comparable to the Earth. So, don't you think the force of gravity will be different? And what will be the force of gravity and the force of, like this one? You can apply Newton's law of gravitation, this one, or you can simply apply the equation of the gravitational field strength, which says gm over r square. So, first of all, let me show you that this is a gravitational field strength of the earth, right? So it is better if I use here the capital R because it is placed over the surface, right? Now, what is the gravitational field strength of this planet? So its mass is m over 3, right? M over 3, and its radius is twice. So which means that it will be 1 over 12 into gm over r square. It means that comparable to the Earth, its gravitational field strength is 1/12. Okay, which actually shows us that it have a very weak gravitational field. So if I have to show you the gravitational field strength of this planet, so I will just use a fewer lines to show you the gravitational field. Right now we have a same block placed over this. Okay. Now, what about the weight? Weight is 1/12, right? So I will just use a small vector, right? This is the 1/12 of mg, right? Because the gravitational field strength is 1/12. And in the same manner, the normal force will be also equal in amount and obviously less. And this kinetic friction will also decrease by how much factor? It will decrease by this factor. Why? Because it is equals to mu times normal force. If the normal force is mg over 12, then it should also be equals to, yes, it should also be equals to f0 over 12. So it means that the frictional force, kinetic frictional force, is reduced by 12 times. So the right answer should be option A.